Welcome to the Lewis structures of aniline. Aniline is a benzene, but with an amino group on it, an NH2. This has Lewis structures. The most obvious Lewis structure is the same benzene ring, but with the electrons delocalized, just FYI. Now you probably knew that already, just because there are no double and single bonds in benzene. They're all 1.5 bonds, and the electrons are delocalized in the whole ring. But this is technically a resonance structure because the electrons are displaced while the atoms are still connected in the same way. The question is, how do you create more resonance structures? And the answer is, the only freedom you have right now is to take this lone pair of electrons on the N and move it to create a double bond here. But wait, you can't do that yet because this carbon already has 8 electrons around it, and that violates the octet rule. You're damn right it does. But this double bond can break open and the lone pair will sit on the carbon atom. Weird, I know, but check this out. We've got our benzene ring. We've got our nitrogen connected here by a double bond, and we have our lone pair of electrons sitting here. The other carbons are unaffected, but what we have is that the electrons have been pushed to this carbon, which still satisfies the octet rule. It's connected to this carbon, a hydrogen which isn't shown, and this lone pair here. But in any case, this is a resonance structure, and we will explore that a little further. What can happen here? Well, this lone pair of electrons doesn't necessarily just want to sit there. Maybe it wants to go back into the ring. It can't go back this way. I guess technically it can, but that just pushes this double bond back to the end, and we're back where we started. If we want to keep going, we got to push that lone pair farther into the ring, but that forces these electrons out, and they end up as a lone pair on that carbon. We end up with our lone pair here. We end up with double bonds between those two carbons, and we have our NH2 here. We can keep going with this. We have this lone pair pushing its way back into the ring, and this double bond breaking open, being pushed to a lone pair on this carbon. So we still have our hexagon, which are getting bigger for some reason. Lone pair, and still with the double bonded NH2. Man, that double bonded NH2 really messed up this ring structure, would you agree? And then finally, we can have this lone pair push its way back into here, which ends up pushing this electron pair back to the N. That gives us our good old NH2 back, but we have our ring oriented this way with the double bonds between these two carbons and these two carbons and these two carbons, which I had already drawn for you. They're the exact same thing, so you wouldn't want to draw them twice. But these are all the Lewis structures for aniline. You end up having to push the lone pair of electrons from the nitrogen into a double bond, and that forces the electrons in the ring, the delocalized electrons, to be preferentially on this carbon, and this carbon. Carbons 2, 4, and 6. Or rather, the ortho and para positions relative to the amino group on the benzene ring, if you're familiar with that. The last thing that I want to point out that I haven't shown here is that once you have a double bond on the N, it ends up with a little charge of +1, or a formal charge of +1, I should say. And whatever carbon has the lone pair of electrons actually has an extra electron relative to before, so it gets a formal charge of -1. Whether or not your teacher wants you to show those, depends on your teacher. I like showing them because I like to be complete, and I like to leave everyone fully satisfied at the end. Speaking of fully satisfied, I'm fully satisfied by this, and I hope you are too. Best of luck.